Hello and welcome to week 4 in statistics. And even though this chapter, sampling, is early on and certainly you've heard about it, I cannot underemphasize the importance of this particular chapter in terms of sampling. And let me go through what's going to be required, then let me give you a little something about why sampling is so important to understand. So in the discussion to go along with this chapter, we're going to be talking about probability and odds. Okay, and that's going to come up with what we talk about when we talk about sampling. There are odds for everything. There's a certain amount of risk that you're going to be hurt by a TV falling on you. There's a certain amount of risk that you'll be in an airplane and it will be involved in an accident. There's a certain amount of risk that you're going to win the lottery. And every day we play out our lives, most of the time unaware of those odds that we are the assumptions that we're making and the odds of something happening. Of course, the media gets that. The safest way to travel in the world is by airplane, but yet people have far more fear of flying than driving, which is probably one of the most dangerous, statistically, ways of traveling. So what I want you to do is look up some odds. Look up some of these things that you can even start, what are the odds that, press enter and see what Google comes up with, in terms of all the things that have been calculated in terms of what's the likelihood of something happening to you, something very strange happening to you, those kinds of things. So we're going to have a discussion about that, kind of get our head wrapped around probability a little bit. Probability is a very important part of understanding why we sample things and what we can say about when we're sampling. Now in the quiz has you look at 3 prospective studies, and I include in there for each one, I include the sampling method I want you to use, and I want you to tell me how you're going to do it. So there's stratified, cluster, and convenient sampling, and I want you to tell me how are you going to apply it to each one of those studies. Be specific. Don't say, well, I'm just going to, I'm going to cluster them together and do that. No, I want you to define what the clusters would be. I want you to define what the stratifications would be, all for the purpose of creating what we call a representative sample, which I'll be telling you about in just a moment. In the assignment, I'm having you use Excel simply to generate a random list of numbers between 2 points. This is a tool that we use when we have, let's say I wanted to randomly select students across the campus at KVCC. Let's say there are 850 students at KV. I can use Excel to say, give me a number between 1 and 816 or whatever I said, and give me 50 random numbers in there. Now, of course, Excel is going to go right into the decimal points and stuff like that, but you just get away from that. Look at the whole numbers, and it might give me 720, 526, whatever. It might give me those numbers, and I take those 50 numbers, and I line them up with all the names of the students, and I can pick, number 705, then I go back up to student number 12 until I get my 50. And that's a way of randomizing your sample. So why go through all this? When we study human behavior, we're trying to say something about all humans. However, we never have the ability to actually include all humans in our study. We're almost always, if not always, using a sample. Now, it's been discussed in this class numerous times. It's been discussed among this particular group in previous classes about, hey, that's a sample. What does that say about me? I don't think that's right because that's a sample or whatever. What is it about that particular group that might be unique? And that's the whole thing. Because the ways in which we go about picking the people that we are going to study when we're actually collecting data, the methodology points to our efforts to make that group representative of the group we want to generalize to. So if I was going to go and do a study at KVCC, and I wanted to study, let's say, the effectiveness of math on something, whatever. I don't even have to really come up with an example per se, but I want to make a study, and I want my study to be representative of students at KVCC. Students at KVCC become my population, and I don't have time to do a study on all 800 and something usually, so I'm going to do a study on a sample. Now, when I look at what I'm studying, I kind of figure, well, what are the demographic factors of this population, students at KVCC, that I should consider in compromising its representation in my sample? So let's say we knew that 70% of the students at KV were women and 30% were men, and there was a small number that were in the other or non-binary category. And I would think, okay, in terms of my study, could gender be an issue? Could sex be an issue? Whichever one I'm going to use. And if it is, I'll collect that data, and when I do a sample about my population, I want to make sure that 70% of my sample is women, 30% is men, so that my sample looks like the population. Now, what about age? What about GPA? What about majors? What about where they're located? What about income? What about any one of those factors that we think may play a role in distinguishing this group to make it similar to the population in regard to my study? I want to make sure that my sample looks an awful lot like that one, like the population. Usually when we encounter studies that have been done, in fact, a major part of the peer review process is the sampling method. That's looked at and saying, okay, does your sampling method reveal enough attention to detail that the conclusions you draw about your population are real? And oftentimes they're not. And those results never make the grade. You don't see them. Now, that doesn't mean that private, when you have an advertising company doing that, they're under no obligation at all to adhere to scientific sampling procedures. In my day, there was studies that were, there was a commercial that dentists will advise, Dentyne, 3 out of 4 dentists will recommend Dentyne for their patients that chew gum. That was kind of like the byline for Dentyne. They're under no obligation to make that fair. They could review people. They could find 4, 3 of which would recommend Dentyne, 1 that wouldn't, and they could say 4 out of 5, 3 out of 4 dentists prefer Dentyne. There's no obligation for them to be truthful about their revelations in terms of their statistical data. In published work, again, this is separating itself from the media's use of sampling. In published work, and often with things like the Pew polls that go out, or when political activist groups and stuff like that, those are often under the scrutiny of, did you collect information from a representative sample? And if not, it might skew your data. And if you're motivated for it to skew in one way, all you have to do is be selective about who you include in your study, right? There's an honesty factor there. What happens in peer-reviewed work most of the time, certainly not all the time, but most of the time, is the sampling comes under the scrutiny of people who are not involved in the study. and hopefully don't have a vested interest in what's going on. So if they look at the sampling method and they find out that no, you have errors in your sampling, then the conclusions that you draw are not necessarily valid. They could be, but they're not. The reason why they are not valid if we don't adhere to scientific principles in our sampling is because of the odds. Beginning here, when we look at the role of numbers playing in decisions, what we are always hoping to determine is the results that you got, whichever way it goes. What is the likelihood that this came about by chance? Meaning, chance has a lot of different ways of happening. You could you did all the right things, but you just got all people who think a particular way. Or maybe your sampling was biased, whether you knew it or not. Or whether inherently your sampling is biased because of where you did the actual study. So years ago, there was a study that came out about high-speed bandwidth in Maine, and it was found out that 85% of Mainers had access to high-speed internet. This was used as an argument for an influx of money into all of the colleges across Maine to develop online courses and to develop their programs to go online. That happened at KV and everything. Here's the interesting thing. The problem with the study wasn't that the statistics were inaccurate. It's that the sample occurred in Cumberland and York County. All of their samples came from Cumberland and York County. No Somerset, no Aroostook, no Sagadahoc, none of those other counties which would have changed those statistics dramatically. The access to high-speed internet is not equitable across the state. And you can see the problem wasn't the data, the problem was their sampling, and their sampling turned out to be biased. So when we look at published studies, particularly under the guise of peer review, to a degree, and we ask the question, and usually within the context of the article, they'll explain their sampling method and the validity to which we apply conclusions they make is related to the accuracy of their sample being representative of the population they're trying to describe. So what happens in the real world is we try and we fail to have representative samples. And then that doesn't necessarily keep us from publishing, but it does keep us from drawing too many conclusions. And we might even discuss the limitations of our study based on our sampling method. My dissertation study had a small sample of people in Maine at a community college taking online classes. That's a smaller and smaller demographic. The results of my study cannot be carried too far before I start being in violation of the restraints and limitations because of my sampling method. And so that's how the knowledge builds. Someone could replicate my study, but do it with a different population, and those two studies together make the results more valid. Just more knowledge coming on. Again, it's not that you don't publish. It's not that you don't go along with that research. It's not that you don't think that good information comes from it. But sampling determines the ways in which we can generalize that information. If you are reading something in the literature, peer-reviewed, or you're looking at institutions that are relatively non-biased, like the Pew Research Center, or some of the studies that you see, you look at the source, it's probable that if it made it that far, it's been through the gauntlet of its sampling method, was evaluated, and found to meet the criteria of the conclusions. Now, we then have to set limits on ourselves. We can find information out there, even with a good sampling method, we still don't want to run with it. We don't have enough data to say anything about everyone or everyone in a group or anything like that. That's, again, the discipline of thinking within psychology We do a sample, we find something out, and we say, I have evidence that points in this direction. That's it. That's all you can say. Sometimes that gets carried too far. Sometimes it gets carried into public policy. Sometimes it gets carried into pundits talking about this and that. There's really false representations of data. And this particular chapter really hones in on the notion that of how important sampling is in determining the validity of your study and how far you can take it, how far you can take the results and assume that they apply to other people that weren't in your study. So there's a discipline of thinking. It is the first task when you're, developing a study, is to come up with, how am I going to collect my data? How am I going to sample the data? And so it's a very, very important chapter to kind of get through that knowledge base so that you can understand the role of sampling in research. So off you go. I'll see you in the discussion boards and have a great week.